I'm Ben, and welcome to my channel, where I talk about all things mechanical engineering. This is going to be another SolidWorks video, specifically Assemblies in SolidWorks. Assemblies in SolidWorks are groups of parts put together in order to model a complete design. They are in essence an assembly of parts, which is what most real-world products and designs are. To create an assembly, you can either start from a new document and create an assembly. You can create an assembly from the home screen here, or if you have a part open, for example this post part, you can go File, Make Assembly from Part. Generally this is the method I use because I start by modeling the parts I need for an assembly, and then I choose a part and I click Make Assembly from Part. And here when you do this, you'll notice SolidWorks opens up an assembly. And if we click our post part and place that in the workspace, we now have the beginnings of a new assembly with post. You'll notice there's an F by the post part here. That means that the post is automatically fixed. However, SolidWorks doesn't necessarily fix the post to the origin of the assembly. And that's an important step to take if you're doing any of the certification exams for SolidWorks. So I'll right click on that and I'll choose float. Now the post is free to move. You can see there's a minus sign here, and it can move about and rotate in the workspace. You can move by left click and drag. Right click and move is to rotate. If I want to fix this post to the origin, I'll need to create a mate. Mates can be found in the Assembly tab. Click Mate. Then I want to find the origin of this assembly and the origin of the post, and it'll automatically choose a coincident mate, and I want this check mark align axes, I want that checked. So I'll accept this mate with a green check. Now the mates window will automatically stay open. Right now I don't have any more mates to make, so I'll click the green check. So that's how we open and start an assembly. I've done this with the post part because what I'm going to do is make this basic door and hinge assembly shown here. And what you see is sort of an example of what we'd see on a certification exam, and I think it's a good place to start for this video. On a certification exam, you see these instructions: download, attach zip file, and open it, save the parts and open them in SolidWorks, and then you want to create an assembly with the origin at the post part origin. That's what we just did a minute ago. I'll give you a few more information on maybe some different mate types or things you need to be aware of in your unit system. Generally it's going to ask for the center of mass, so we'll check that after we make our assembly. So minimize this. If I go to Windows here, you can see I have all the different pieces already opened. There's the post, which we're seeing. I have the door piece. I have both hinge pieces. And then I have the pin piece. So let's go to our new assembly, and let's start creating this assembly. You can insert components here from this Insert Components button. If you select that, let's start with let's look back at our assembly. The hinge with the centerpiece is attached to the post, so we'll find hinge center and place that in the workspace. Now we're going to need two, and I can either go Insert Component again and add another one. Another trick is if I press Control and click, I can drag, create a second hinge. When I release my mouse in the workspace, I now have another piece, another hinge center. This is a useful trick if you have a lot of the same types of parts in an assembly. You can quickly copy them. So let's start by adding some mates to this piece. So we'll open the Mate tool. I'm going to start with a coincident mate of my faces. So I want this hinge mated coincident to the post. And then I want my holes here, where there would possibly be a bolt or a screw. We didn't include that in this assembly for simplicity. I want that concentric. Now I'm going to use, if I want to, I could lock rotation, but I'm going to leave that unchecked for now, because I'm going to do a second concentric mate with that second hole. And now, if I click the check mark, we can see our hinge center has no degrees of freedom. It's completely locked in place. For most assemblies, if you're not doing a motion study, it's best to make sure everything is properly constrained. It just makes it easier for drawings, for section views, and ensuring you have things where they're supposed to be. So let's repeat those mates again for our second hinge. Again, the mate toolbar, I'm going to select my two faces to create a coincident mate. And you'll notice here that my hinge is sort of turned the wrong way. So it's going to be easy before adding more mates to orient it the way you want it, close to the way you want it. So what I did is I right clicked and I drag the mouse and I can spin this part, which is still degrees of freedom, and I can move it about as well. So I'll keep adding mates. Just like before, I select those two holes and I want to use concentric. You'll notice if I select this hole here, this part becomes transparent. That lets me easily find this hole in here. I can go select other, and it'll let me select other face. In this case, it didn't give me the face I wanted, but that's okay. We can rotate this part till we can see that hole, and we can recreate our mates as wanted. So now that we have our two center hinges, let's add our pins. In this case, I'm going to select the outer face of the pin, I'm going to mate it to this part of the hinge, and in this scenario, I want to lock rotation because I don't want the pin to spin. I'm going to have two pins, so we're going to go ahead and create a second pin with our control-click method, and again, mate concentric. And in this case, I'm leaving the pins free to slide in and out of this slot for now, so that I can ensure I have the correct spacing when I add the other hinge. So you'll notice they're free to move, so there's a minus sign. But insert the other piece of the hinge, and we'll mate this again accordingly with the concentric mate to the pin. What I want is this and this to be flush, and then I want to ensure it's evenly spaced here. So let's use the measure tool to try and understand how much space we need. So it looks like a distant mate of 1 millimeter will accomplish our goals. So let's select this face of the outer hinge, this face of the center hinge, and let's choose distance. We set this distance to 1. This should be evenly spaced, so we know the distance between these two faces is 1 millimeter based on the mate we just created. Let's double check. Good, 1 millimeter. Now let's reference our example. It said the angle between these pieces was 115 degrees. So we can set that with an angle mate. So I can select those two faces shown and choose angle, and I can set it to 115. That looks just like we want it. And then I need another hinge, so again I'll use the control click, and I'll repeat this same mating process for my second hinge. Again, we want distance 1. Now we can create this, so we can set the angle of this two ways. We can use another angle mate, or I can make these two faces coincident. And so now, if I need to change the angle, I just have to find one angle mate, and that'll adjust the angle of both hinges. And the last thing I need to do is mate my second pin to the top of this hinge. And we need to insert one more component. It is the door part of this component in this assembly. And we see we have our screw holes on this side. So it's a few simple mates, just like with a post. We're going to mate this front face to this face. And then I'm going to use more concentric mates to make sure I align my bolt holes. Okay. Now that we have our assembly made, we can check our center of mass. We can do that from the Evaluate tab, find Mass Properties. That brings up this Mass Properties window where we can find the grams of the full assembly and the center of mass. So let's go back to our example and check that again. We'll notice with 2 decimal places, our center of mass matches. And this is how we would check our work on a certification exam. This is how we would show that we assembled things properly. If you made it this far, thanks for watching. We covered how to create assemblies in SolidWorks and a few of the different mates you can use. There's lots of different mates and lots of different ways to constrain parts in an assembly. But this was just the basics. I think the best way to get familiar with creating assemblies is to practice. There's tons of examples online, and it's just best to get in and get working in SolidWorks. So if you made it this far, thanks for watching. I hope you found it useful and liked it. If you did, please press the like button and subscribe.